Hi guys, welcome back to my channel. For today's video, we're going to discuss rational functions. So it's one of the lessons under general mathematics. Now for my students, if you would like to read more about this specific type of function, you may read your books from page 56 to 74. Okay, so when we say rational, the synonymous words for this are reasonable and logical. Okay, so when we say being reasonable and logical, it applies most on a human person wherein we are upright thinkers. So therefore, that's why we are actually here running the world. Okay, now it's it's from the word ratio, wherein when we say ratio, it denotes fraction, it denotes division. Okay, so therefore we are going to talk about fractions or algebraic functions that are in the form of fractions. Now, let's compare rational and not rational. So rational, as you can see in the left side, so we have y is equal to x minus 2 over x plus 5. Y can also be written as f of x. Okay, just remember that this one is an example of function. So we have an algebraic expression in the numerator, and then we also have an algebraic expression in the denominator. That's why this is a rational function. Same as well with the second example. How about this? So in this, so as you can see, this is an absolute value function because we have a specific term wherein we have an absolute value term. And then the other one in the previous videos, we have 4 raised to the x power, and this one is an example of exponential function. So they are more of absolute value function and exponential function other than rational functions. So rational functions, we're just talking about algebraic fractions, algebraic expressions in the form of fraction. Okay? So let's differentiate rational expression, rational function, and rational equation. So when we say rational expression, it is the quotient of two polynomials, just like what you are seeing. We have a polynomial in the numerator. We also have a polynomial in the denominator. That's why this is an example of merely rational expression. And then the other one is rational function. It is a function defined by a rational expression just like this. So the f of x is equal to 2x minus 1 over 3x plus 4. We have the domain and also we have the range. Okay, so just remember that you cannot solve for the range without the domain for a specific functions. Two polynomial functions expressed in quotient just like this. And then for rational equation, of course, it is an equation with at least a fraction on one side having a polynomial numerator and denominator. So just like this is an example of equation because as you can see, we have algebraic expressions in both sides of the equation, and then one of the sides has actually rational expression. Okay, next. Why should you learn this? You should learn this because since we're talking about fractions and ratio, so we can apply this in the following fields like average sales over time. So if you would like to compute for the average sales over time, just remember to add and then divide it to the number of days. Then we also have average speed over distance. So if you are traveling, so it's if you would like to compute for the speed, it's just the ratio of distance over time. And then we have the concentration of mixture for chemists. And then these are just some of the problems that illustrate rational functions. Okay, so let's talk about rational functions. When we say rational functions, it is the quotient of two polynomials and can be written as r of x is equal to p of x over q of x, where q of x is not equal to 0. So in this case, as you can see, the denominator cannot be equal to 0 because for all we know, in a fraction, if the denominator is 0, the value of the whole fraction is undefined. Okay, so that's why q of x is not equal to 0. So this is how we are going to illustrate and visualize the graph of rational function. So let's say the graph of f of x is equal to x over x minus 5. So as you can see, we have two curves for for this specific rational function. And then there are also software applications that you can use in graphing easily this type of functions. Okay, next we have the domain of rational functions. So how are we going to compute for the domain? So let's say we have r of x is equal to 3x over x plus 7. And guys, when we say domain, these are the values of x. Okay, values of x. So let's have this. So r of x is equal to 3x over x plus 7. we have to simply set the denominator to 0 and factor to find the illegal value. So let's say this is the denominator. Just take the denominator, and according to our instruction to get the domain, equate the denominator to 0. Again, just the denominator. We don't care about the numerator. Okay, so x plus 7 is equal to 0. And then, of course, we need to transpose positive 7 to the right to solve for x. So positive 7 and the opposite of positive 7 is negative 7. That's why the value of x is negative 7. And then, so this one is what we call the illegal value, which is negative 7. So when we say illegal value, these are the values that cannot be substituted in the denominator because it will make the denominator 0, and that if the denominator is 0 according to our previous slide, so the rational function will become undefined. So in this case, so if we're going to substitute negative 7 plus 7 is 0, and of course we cannot have a denominator of 0. That's why we call it illegal value. Now, how are we going to write the domain? So we're going to write the domain in this form of a representing relation or function. So the domain will be x is an element of real numbers such that, okay, x is not equal to the illegal value, which is negative 7. So what do I mean by this? All of the values that are not negative 7 are the elements of the domain of this function 3x over x plus 7, except for negative 7. Why? Because it will make the function undefined. That's why we cannot have negative 7 as one of the x values or domain. Okay? Next, let's have r of x is equal to x minus 2 over x plus 3 times x minus 3. So just remember, we have to get the denominator and then equate to 0. So in this case, as you can see, we have factored two binomials. Okay? So how are we going to compute for this? So to compute for this is that we have to get the two values and equate them to 0. So we have x plus 3 times x minus 3. So we will be having two illegal values here. So let's start with x plus 3 equals 0. So x plus 3 is equal to 0, and then transpose positive 3. This will become negative 3. And here, it's x minus 3 equals 0. Transpose negative 3. This will become x equals positive 3. So as you can see, we have two illegal values now, guys. So since we have two illegal values here, we can just simply write the domain. So the domain will be, x is an element of real numbers such that x is not equal to negative 3 and x is not equal to positive 3. So therefore, we can have all the elements in the universal set except for negative 3 and positive 3. Why? Because these two will make the denominator 0 and the whole function undefined because of the denominator of 0. So that's how we get it. So both polynomials were equated to 0 to get the values. Okay? So again, we have x is an element of real numbers such that x is not equal to negative 3 and x is not equal to 3. So remember to use the unequal sign, okay? Unequal sign. If you will be using equal sign, you will be getting a wrong answer for the domain here. Next, let's have this. R of x is equal to 3x minus 1 over x squared plus 5x plus 4. So as you can see, we have to get the denominator of this, and then as you can see, the denominator is not factored. So we will be factoring first the denominator to get the two binomials that will become the basis for the illegal values. Okay, so we have to factor using the cross method. This is the easiest factoring method that we can use. So here we are going to factor the first, the last to get the middle. Since they are both the second and last terms are both positive, so we are going to have both positive factors for the binomials. Okay. So this is 5, and then factors of 4, we have 4 times 1 equals 4. So they are both positive. So we will be factoring x squared. We will be having x and x, while positive 4, we will be trying 4 and 1. 4 times 1 is 4. And then cross method, x times 4 is 4x, x times 1 is x. So if we're going to add them, 4x plus 4x is 5x. As you can see, that's the middle. So therefore, the factors are correct. So the factors are x plus 4 equated to 0 and x plus 1 equated to 0. So transpose positive 4, x is equal to negative 4. Transpose positive 1, so therefore x is equal to negative 1. So therefore, we're going to have now we're going to have now these two illegal values. We have x equals negative 4 and x is equal to negative 1. So therefore, the domain will be x is an element of real numbers such that x is not equal to negative 4 and x is not equal to negative 1. So these two illegal values will not be part of the domain since it will make the whole equation 0. Okay, next. Okay, next. This is the flow. We factored, we got x plus 4 and x plus 1, and then afterwards we have x plus 4 equals 0 and x plus 1 equals 0, and then transpose both positive 4 and positive 1. You will be getting x equals negative 4 and x is equal to negative 1. So therefore, the domain is x is an element of real numbers such that x is not equal to negative 1 and x is not equal to negative 4. That's how you solve it. That's how you factor. We use the cross method. And then let's have this. R of x is equal to 4x plus 2 over x squared minus 4. So just get the denominator. We have x squared minus 4 and then equate to 0. Isolate x squared by transposing negative 4. So x squared is equal now to the opposite of negative 4, which is positive 4. And then to solve for this, you have to omit the square symbol is the square of the x of variable. So by extracting the root or square root. So therefore, this will be x and square root of 4 is positive negative 2. And just remember that since we have positive and negative 2, we have two values, positive 2 and negative 2. So these are the illegal values. The other method is by applying the special product, wherein x squared minus 4 is a sum and difference of two binomials because, as you can see, both terms are perfect squares, and also we have subtraction symbol at the middle. But so if we have this, we will be having the two factors, x plus 2, x minus 2. How did we get that? The square root of 4 is positive negative 2. And then same thing, if we're going to equate them to 0, you will also be getting x is equal to 2 and x is equal to negative 2 as the illegal values. So we can now write the domain wherein x is an element of real numbers such that x is not equal to negative 2 and x is not equal to positive 2. So just remember to use the unequal symbol for this. Okay? So that will serve as our final answer. Okay? You can also interchange this for as long as you have the correct illegal values. Okay? Next. Let's have the vertical asymptote. Just remember when we say vertical asymptote, it's just the value of the illegal value. Okay? So there will be a vertical asymptote at any illegal x value. So anywhere that would make the denominator equals 0. So example, let's have this. So after solving the illegal value, that is already our vertical asymptote. Okay? So let's get the denominator. Okay? And then how did we get x minus 4 and x plus 1 for this? Just remember to use the cross method wherein we are going to factor this and this to get the middle term. Okay, factors of x where we have x, and factors of negative 4 since they are both negative. So one will be positive, one will be negative. So let's try negative 4 and 1. Okay, and then cross method, x times 4 is negative 4x and x times 1 is positive x. So if we're going to add them, negative 4x plus x is equal to negative 3x since they are the same. Let's subtract, copy the sign of the higher number. So negative 3x is the middle term. That's why we will be getting this 2. And then the illegal values, just simply transpose negative 4 and positive 4. Okay, so you will be getting the two illegal values, x is equal to 4 and x is equal to negative 1. So these illegal values are also what we call the vertical asymptotes. So when we say vertical asymptotes, these are the two lines. Let's say x equals negative 1 and then this is x equals negative 1 and then this one is x equals positive 4. So these are the lines wherein the curve will not touch. Okay, will not pass through, just like this. Let's say that's the graph of the rational function. So as you can see, that's the use of the vertical asymptote. Okay? So when we say vertical asymptotes, these are just the illegal values or values of x. Don't be confused of that. So let's have this. Determine the domain and vertical asymptote of the given function. So just get the denominator wherein x minus 2 is equal to 0. Therefore, x is equal to positive 2. That is our illegal value. So our domain will be x is an element of real numbers such that x is not equal to 2. Okay, so that is our domain. And then for the vertical asymptote, it's just simply x equals 2. As simple as that. Don't be confused. So we know now how to solve for the domain and the vertical asymptote, or how to write for the domain and solve for the vertical asymptote. Okay? Again, the vertical asymptote is just the value of x. Next, determine the domain and vertical asymptote of the given function. So first, we have to factor this using cross method. We have x and x for this, and then since this is negative 2, 1 is positive, 1 is negative. Okay? Cross method, 2x, negative x, add 2x minus x is equal to positive x, which is the middle term. So therefore, the factors are x plus 2 and x minus 2. And then, equate them both to 0 and then transpose positive 2 and negative 1 to the right. So we will be having x equals negative 2 and x is equal to 1. So these two values are the illegal values. So how are we going to write the domain? So x is an element of real numbers such that x is not equal to negative 2 and x is not equal to positive 1. That's how you write the domain. And then for the vertical asymptote, these are just simply the illegal values. X is equal to negative 2 and x is equal to 1. So just remember to use the equal sign, but not for writing the domain. Okay? Next, if we have the x value or the vertical asymptote, we also have the horizontal asymptote, okay, or the y value. So we compare the degrees of polynomial in the numerator and denominator that tell us about horizontal asymptotes. So for case number 1, if the degree of the numerator is less than the degree of the denominator, the x-axis is the horizontal asymptote. This is along the line y is equal to 0. So, and then for case number 2, if the degree of the numerator is equal to the degree of the denominator, then there is a horizontal asymptote. Y is equal to the leading coefficient of the top and over the leading coefficient of the bottom. For case number 1, when we say degree, these are the highest exponent within the term. So in this case, we have for the numerator, the highest exponent is 1, and then for the denominator, the highest exponent is 2. Okay, so just get the highest exponents, compare them if they are equal or not. If they are not equal, and that case is case number 1 because the numerator is less than the degree of the denominator. So automatically, the horizontal asymptote is just simply y equals 0. As simple as that. If they are not equal and the degree of the numerator is lesser than the degree of the denominator or the highest exponent of the denominator, automatically the value of y or the horizontal asymptote is just simply 0. Okay? And let's go the second one. So as you can see for case number 2, equal. So the degree of the numerator is equal to the degree of the denominator. So therefore, just get the coefficients. Here we have 1. Okay, so if you're not seeing it, it's 1. Okay, just get the 2 and then divide 7 over 1. So the answer here is 7. So the horizontal asymptote for this is 7. Okay, so just if they are equal or if the degrees are equal, do not divide the degrees, rather divide their coefficients or the numbers beside them. Okay, so in this case it's 7. So I do hope that it's clear to you how to solve for the horizontal asymptote. Okay, determine the domain, vertical asymptote, and horizontal asymptote of the given functions. Okay, we have x squared minus 9 is equal to 0, wherein if we're going to solve for this one, just simply transpose negative 9. Okay, it will become positive 9 and extract the root of both sides. We will be getting positive negative 3. So therefore, the illegal values will be x is equal to 3 and x is equal to negative 3. Now let's have the domain. The domain will be x is an element of real numbers such that x is not equal to 3 and x is not equal to negative 3. And the vertical asymptotes are just simply the values or the illegal values. Now, for the horizontal asymptote, just compare the degrees. They are not equal because the numerator's degree is lesser than the denominator's degree. So in this case, automatically the value of the horizontal asymptote is 0 since the degrees are not equal. Now, for the second one, we have f of x is equal to 3x plus 1 over x plus 1. In this case, x plus 1 is equal to 0. Transpose positive 1, it will become negative 1. So therefore, the domain of this will be x is an element of real number such that x is not equal to negative 1. And the vertical asymptote is the illegal value. And then for the horizontal, as you can see, they are equal. This falls under case number 2 wherein you need to divide 3 and 1. So therefore, y is equal to 3 over 1 or simply 3. This is now your horizontal asymptote. So I do that you get to compare case number 1 and case number 2 for solving for the horizontal asymptotes. Okay, now let's have rational equations and inequalities. So how do we solve for the solution set or the value of x for each rational equation or inequality? So let's solve the following. Find the solution set of each equation or inequality below. So we will be solving them one by one. We have two equations. We have four inequalities. So as you can see, we have inequality symbol for each. Now let's solve for the first one. So there are two techniques here. So if both sides of the equation are single fractions, just like what you are seeing, so we have single fraction, just simply cross multiply. Okay, so cross multiply. So if we're going to cross multiply, we will have 1 times x plus 6. Okay, and then the other one, 3 times 4. Okay, so in this case, we just need to do distribution and also multiplication. So 1 times x is x and 1 times 6 is 6 equals 12. Okay, and to solve for the value of x here, we need to transpose positive 6 and it will become negative 6. 12 minus 6, x is equal to 6. So that's already our final answer. Just remember, you can only cross multiply if we have single fractions. Okay, for both sides, just like this. These are these are examples of single fractions. Then for the second one, as you can see, we don't have single fractions because as you can see, okay, we have binomial here. So a fraction and also 1. So if that's the case, all we need to do is to omit the denominator by multiplying all by the denominator that you are seeing 3x plus 3. So in this case, the idea is we will be distributing to each term. Okay, so we will put a bracket, 3x plus 3, we will be distributing each one. So let's start with 2 times 3x plus 3 equals x minus 2 over 3x plus 3 times 3x plus 3. And then 1 times 3x plus 3. So as you can see, we just distributed 3x plus 3 across all. So we will start first here. 2 times 3x is 6x. 2 times 3 is 6. And here we can just simply cancel this because we can divide. And when we're dividing the same terms, the answer is always 1. So what will remain here is just simply x minus 2. And our goal, remember, is to remove the denominator to easily solve for the value of the x or solution set. And here, whatever we multiply to 1, of course, is the number that we multiply to 1. So just like this, the answer is still 3x plus 3. And then the next thing is we will be transposing all the terms with variables to the left and all the constants to the right. So with x, we will put them to the left, okay? So we will have now 6x and the opposite of positive x is negative x. And also we have 3x, opposite of 3x is negative 3x equals, just bring down negative 2 because we did not do anything with it. And then bring down positive 3. Okay? So, and then after that, transpose 6 and it will become negative 6. And then just simplify, 6x minus 3x is 5x and 5x minus 3x is simply 2x. And then equals negative 2 plus 3 is positive 1 and 1 minus 6 is negative 5. And all we need to do is divide both sides by 2. Okay? Divide both sides by 2 to isolate x. So we will now have 2x over 2 equals negative 5 over 2. Cancel 2. Therefore, x is equal to negative 5 over 2. That's already our final answer. And if you would like to make it, we call this If you would like to make it a decimal, it is 2.5, okay, or negative 2.5. All right, so that is example number 2. Again, for example 1, we have single fractions for both sides, and for example 2, we don't have a single fraction in one of the side. That's why we multiply the whole equation by the denominator present. And let's have this inequality 1/3 is less than or equal to x minus 2 over x plus 1. So if we're going to analyze this, we have only single fractions for both. So therefore, we can just simply cross-multiply this. So we will start with 1 times x plus 1. And then the second one is less than or equal to 3 times x minus 2. Then distribute 1 times x is simply x, and 1 times 1 is just simply 1. Is less than or equal to 3 times x is 3x, and then 3 times negative 2 is negative 6. Then transpose to the left all the terms with the variable and all the constants or numbers to the right. Okay? So x and then opposite of 3x is just simply negative 3x is less than or equal to, bring down negative 6 is we did not do anything with it. And then positive 1 will become negative 1. Then simplify x minus 3x, okay, is negative 2x. And then negative 6 minus 1 is negative 7. Then we divide both sides by negative 2 since we need to isolate x. And when you are dividing both sides by a negative or multiplying or dividing both sides by negative, the resulting answer or the inequality symbol must be flipped. Okay? Whenever you multiply or divide the negative number, flip the sign. So just like did we with this, we divided both sides by negative 2. So therefore, the symbol is less than or equal to will become is greater than or equal to 7 halves. And then why is it 7 halves? 7 halves, negative times negative is positive. So therefore, this will serve as our final answer. Right? Now let's have this next. So as you can see, we don't have a single fraction for each side. So we have two fractions here and a single term here. So what are we going to do here is to remove the denominators by multiplying the whole equation by the two denominators 5 and 4. So we will be distributing to each of the terms. Okay, so after distribution, it will go like this. And then, okay, we can just cancel this. So what will remain is 4 times x or 4x. And then after that, we can just cancel this, and then 5 times negative x is negative 5x. Is less than or equal to 2 times 5 times 4. 2 times 5 is 10 times 4 is 14. And then after that, 4x minus 5x is just simply x is less than or greater than 40. And then we divide both sides by negative 1 since as you can see, we still have negative 1 here. And the divisor is negative, so therefore your final answer will be greater than or equal to negative 40. So that's already our final answer. Okay, next let's have this. As you can see, we have a single fraction in the left and we also have single fraction in the right. Okay, so we're going to cross multiply. So after cross multiplying, we will be having 5 times x plus 1 is greater than 2 times x plus 4. Then distribute 5 times x is 5x, 5 times 1 is 5, and then 2 times x is 2x, and 2 times 4 is 2 is 8. And then the next thing that we're going to do is transpose all the terms with the variables to the left and then constants on the right. Okay, 5x and then opposite of 2x is negative 2x. And then greater than, bring down 8. And opposite of positive 5 is negative 5. Then after that, 5 minus 2x is 3x. Greater than 8 minus 5 is 3. And then we divide both sides by 3 since we need to omit this one and isolate x. So therefore, x is greater than 1. We did not flip because as you can see, the divisor that we have, which is positive. So positive 3 is of course positive, and 3 divided by 3 is 1. So that's why our answer is x is greater than 1. Okay, next let's have this. Alright, so as you can see, we have single fraction for both sides of the inequality. Okay, so cross multiply, you will have 5 times x minus 2 less than 3 times x minus 3. Distribute 5x. And then 5 times negative 3 is negative 10 is less than 3 times x is 3x, and 3 times negative 3 is negative 9. And then put in the left side all the terms with the variable and the right side constants, okay? So 5x and opposite of 3x is negative 3x is less than, so we transpose positive 3x, and then less than, bring down negative 9, and then we transpose positive 10, it will become, we transpose negative 10, it will become positive 10. And then combine 5x minus 3x is 2x is less than negative 9 plus 10 is just simply positive 1. And then we divide both sides by 2 to isolate x. And then we will not flip it or the inequality symbol because as you can see, we have a positive divisor. Okay, so the final answer is x is less than 1 half. Just remember in your final answer, if it is inequality, just use the inequality symbol, not equal sign. Okay. And then for my students, please accomplish this. And thank you so much for listening, staying in my video for today. So thank you so much and hope that you learned a lot. Have a nice day.